Hi and welcome to the lesson on the equation of a line. This is really for those who weren't here the last class. I think it was last Tuesday. This gives you just a bit of an idea of what we covered in the class. There's a couple of extra things that I won't include in this video, but they won't be too important. I could just catch up with you another time. But here's the equation of the line. What I want to do is, up until this point, we've actually been given a rule for the line, so y equals mx plus c or something. And we've had to draw that line based on the rule that we've been given. But now I guess I want to ask the reverse question. I want to say, if you've been given a line, I want you to tell me what the rule is. So for example, I've got this line just here that goes through these 3 points. I'm going to say that this first point is called x1 and y1. Okay, the first x point, the first y point. And I want to call this this point here that it goes through, I want to call x2 and y2. This third point, this one in the middle, I actually want to call it a floating point. The reason I use a floating point will become apparent later on, but I'm actually going to call this point here x and y. Okay, so it's a generic x and y. X and y can change. It's a floating point that can kind of be anywhere along the line. Okay, and now what I want to do is I want to get the gradient between some of these points. Now I know that the gradient for this line will always be the same because it's a straight line. It will always have the same rise over the same run. So I'm going to use the first gradient, which is here. M equals, let's say, y minus y1 over x minus x1. So this is the first gradient I'm going to find out. And I'm also going to find out the second gradient, which will be y2 minus y1 over x2 minus x1. Okay, so I've got both of the gradients here. This is the one you've normally seen, the second one, but I've also got the other one as well. Now I also know that because the gradients are the same, I can actually make these two things equal each other. If m1 equals m2, that's true because the gradient's always the same, then I can say y minus y1 over x minus x1 equals y2 minus y1 over x2 minus x1. Okay, which looks a bit ugly, but it's actually quite helpful. What I'm just going to do is just going to rearrange that to make it look a little bit nicer. I'm going to say that I'm going to multiply both sides by x minus x1. So I get y minus y1 on one side, and I've got this gradient formula here that you guys have seen before. Y2 minus y1 over x2 minus x1. Whoops, that last one should be an x1, and then that's all multiplied by x minus x1. And what we've actually got here is we've actually got the equation of a line. We can use this information here to find out if we had two random points, we could find, and it's a linear graph, we could find out what the equation is. Just bearing in mind that x1, y1, x2 and y2 are all just numbers. They're actually points on the graph. And this x and y is also a point on the graph, but it's a floating point. So in your answer, when you sub these numbers in, x1, y1, x2, y2, you'll have y and x as the standalone things. Okay, I might just give us a quick example just to make things a little bit easier, just so you know what I'm talking about. So imagine I've got the 2 points here. I'm going to make this point, I'll make that what would I make? 0, 6, and I'll make this one -6, 0, just to make it a little bit easier. Now there's other ways that you could find out the equation of that line, and I really don't mind if you use y equals mx plus c and find it out, but I want to show you using this formula here. So I'm just going to call this one here the x1 y1 point, and the other one will be the x2 y2. It really doesn't matter as long as you're consistent and you do the right thing the whole way along. So y minus 0 equals 6 minus 0 over 0 minus -6, x minus -6. Okay, and y minus 0 is just y. 6 over -6 will be, sorry, not -6, there's negative, positive, so it'll be 1 times x plus 6. So this equation is x plus 6. And there we go, that's the equation. So this formula can be really helpful in finding out the equation of a line. So that's what we did the other day, and I guess I'll catch up with you more with the other things that we missed at another time, but that's it for today. Thanks for watching.